Hi, and welcome to our third class on Python for data. So if you've missed any of our previous sessions, you can go through the playlist and then watch the previous sessions. It will help you better understand what we have here. In our previous session, we were able to do a few things with lists. We were able to create lists. We were able to access their elements. We're also able to add, write, and remove elements from lists. And we were also able to order the elements of a set, that is sorting them either in a particular order, either ascending or descending. We're also able to see how to index, sorry, rather slice our elements, that is the elements in a list. So this week we just build on what we learned earlier, of course. And we are not just creating lists now, we are learning how to work with lists. And the first thing we're going to be seeing is looping through an entire list. Now, this becomes very handy if you want to carry out a particular operation for every member of a list. There are times where you have a list containing the names of people, and then for each member of the list, right, or for each name in the list, you would want to carry out a particular operation for, or the same kind of operation for each member. Or let's say you have a list containing numbers from 1 to 10, and you want to add 10 to each element of the list. So supposing we have a list, we just create a list like from the last class, just to kind of revise. Let's say we have Aisha, and let's say we have James, and let's say we have Muhammad. Okay, so we have this list. Now, you of course you run this. If you print names, you should have this list, of course. So now let's say we are moving away from just printing the list. We want to print these names that are here already, right? So a simple way to see is, okay, want to print, right, um names, 0, right? You come again here, want to print names 1. We want to print names 2. So that's how you print all the elements of this list, right? Now imagine if you have 1,000 names, it means you have to be writing this manually, and that will take you a very, very long period of time before you finish, right? We're going to see how to make that very, very easy with loops. But of course, this is what you get. Let's run this and see. Okay, I think the network. Okay, what if I want to print like a message to all of these guys? So I can just run print. Remember our message. Good morning. Then I pass in the name of the person, which is going to be name 0. So if I want to greet all of them, another way I can do is I can be copying and be pasting, right? Then I can come and be changing the numbers. That in itself is also not a very optimal way of doing it. Like I said, if you have a lot of elements in the list, right? Right. So that's better. And another reason why you might want to loop through your list, apart from the fear that the list might get very, very lengthy, the list might get updated. And so if it gets updated, you don't know the actual number where it will stop. So it means you have to come and update your code each time the list gets updated. You can see if you're going by this method. Oh, another way, yeah, another reason why you would want to loop through your list is because you don't want the codes to be very, very long. And it's actually very, very inefficient for you to have 1,000 lines, right? And sometimes the instructions for just one particular member of the list might be more than one line, right? As you can see here, we just have a line, just good morning. Sometimes they can be two, three, four, five, 10 lines for just one element of the list. And that's inefficient for you to do them manually like that. And that's where looping comes into play. And we're going to be seeing looping as we continue to go, because we'll be using fairly lengthy lists. And especially when you go to the data space, you have long lists that you're going to be working with. Right. So I really don't know why this is taking so long to run. I think it's the network. Let me just disconnect and reconnect again. We're back. So we run this. Of course, we have these names, right? So I told you that there are better ways actually we can go about this. And then what if I print? What if I run this? Of course, it greets good morning Aisha, James, and Muhammad, right? Each of them respectively. So now the idea of looping. Let me just use this whiteboard to explain to us the idea of looping diagrammatically, so it helps our understanding, right? So let me create this list, which I just created now. this, let's assume this is the list now, right? I create another, these are elements of the list. Let's assume these are elements of the list. Create another element here. So I have that here. Yeah. So this, let me call this Aisha. Oh, I don't think I got that name correct. Yeah, yeah. I have James, right? And I have Muhammad. Very good. So this is the list. This list now, the name of this list now is called names. So let me type names here. Right. This is the name of the list. Now, what a for loop will do for you is actually to come here. You are now telling it, okay, so for each of these objects here, right? For each of these objects here, I want you to pick an object, carry out this operation on the object. So instead of you just copying and pasting or writing the same instruction each time for each object, we just pass the instruction once and we tell it, okay, so we want you to go through this list and then carry out this particular operation, right? For example, the operation is um let's say a greeting operation, right? Like we had. So what we wanted to do is we wanted to greet, right? Um I don't know if using this will be better. Well, I guess that's what I have. Greet. Beautiful. So we wanted to greet. Um, yeah. Let me see if I can get this text up. Yeah. So we wanted to greet, right? So if now what the for loop will do is that this is the operation we wanted to carry out. Or let me yeah, this is the operation we wanted to carry out, right? So each time it comes here, let me shift this downwards. Each time it comes here, it picks Aisha, it greets Aisha. It comes back, it picks James, it greets James. It picks Muhammad and it greets Muhammad. Instead of us doing it manually, right? Instead of us having Aisha greeting, James greeting, Muhammad greeting, it will join all of them. Yeah. Let me have another arrow here. Same greeting. And then let me have another arrow again from Muhammad, right? So the same greeting that we have. Let me shift this downwards. Beautiful. So the same greeting we have, they are sharing the greeting function. That is what the for loop will do. Because what the kind of looping we're going to be looking at now is the for loop. So we basically have two kinds of loops that can get this job done. We have the for loop and we have the while loop. So for now, we're going to be looking at the for loop. Now, what the for loop does is that it runs for a definite period of time, and I'll explain that. Now, for example, the names of people in this list, of course, is a definite number. There is no way you can tell me that the list of people in a particular organization is indefinite. It's not possible or uncountable. It is they are countable. The list is countable, right? So the for loop goes through the list, right, for a countable number of times. Now, when you do not have an idea of how many times the loop is supposed to, happen, then you use the while loop. But when you have an idea, it's always better to use the for loop. So you might, more often than not, we use the for loop, especially as data people. We use the for loop more than we use the while loop. And then so this just explains what a loop does, right? And I hope you understand. If you didn't, just follow me, you're going to understand. So this time around, here when we come, we are going to, like I told us, we're going to use the for loop, and this is how the for loop statement works. So we'll tell it now for let's say now for item, right, in this list. What is our list now? Our list is names. So for item in names, so basically, where you this is basically English, right? This is basically English, and Python understands this English. You're telling now for each item now in the list called names, right? Now, so Python expects that if you're using a for loop, here should be like an iterable like a list, a tuple, a set, or any other thing. It should be iterable. So a list is iterable. It means you can actually do it for every member of the list, right? So here is just the name we give to each of the variable. For example, the first time this for loop works, it this is like a variable. It attaches item to Aisha. So when it is running for the first time, item is equal to Aisha. When it is running for the second time, item is equal to James. When it is running for the third time, item is equal to Muhammad. And if you don't want the name item, you can actually make it names. Sorry, name rather, for each name in names, right? So that you don't confuse. If you have names here, you have names here. That's a problem. So for each name in names, right? So you add a colon here, very very important, and then you hit enter. Automatically, when you hit enter, something happens. It indents, and then it gives you some character spaces here. We're going to discuss that towards the end of the class. But it gives you an indentation, and that's how you must do it. If you walk If you do anything outside of this indent, you have an issue, right? So we don't want to do anything outside of the indent. We want to stay within the indent. And of course, we're going to talk about that also later on. So what do we want to do now? Now we want to just write the particular instruction we want it to do. We want it to print that name. So for each name in names, in the list called names, we want it to print that particular name. So the first time it picks Aisha, it will print Aisha. The next time it takes James, it will print James. The next time it takes Muhammad, it will print Muhammad. So you can see, instead of us telling it print name zero, print names one, print names two, right? These two lines of code are doing exactly the same thing. Run it and see. Now you have that. And even more powerful, if you come here and let's say you want to print this good morning message, let me just go ahead and copy this guy, come here, paste, and then I'll just take out this guy and just leave name here, right? I wanted to print good morning and then the name of the person. For each time it picks the name, let it print a good morning message. Then let me run this. So that is exactly what a for loop does. So instead of actually writing, and this will work even if you have 1,000 names, right? Even if you have 1,000 names. Let me give you an example with numbers. Let's say we have nums now, and then the nums is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So we can just come here and say for a number, or we can say for x if you want, in nums. Anything, you can use anything here, but make sure that whatever you use here is what you're going to use in the body. Is it, yeah, am I right to call it body of the loop? Okay, in the block of codes here, if you call it that one, you won't be far from the truth. So this will be here. I can just come here and print x plus 10. Then I run this and I have my answer, x plus 10. So it takes each number here, it adds 10 to it. Takes each, now you can see it has saved me a lot of time. Instead of doing this manually, picking the first number, adding, picking the second number, adding, I can just do this automatically and I have that, right? So that's exactly what looping does. Like I explained here, it picks each element here and then this is the function, the loop function, right? This is the function, or this is the task it is supposed to carry out. So it takes each element, carry out this task, takes this one, carry out the task, takes this one, carry out the task, instead of you identifying the task each for every of them individually, like we saw. Great. So don't worry if you didn't understand very well. Just pause the video at this particular moment and then try to go back and watch the video again. Yeah, that works. It's rather try to pause and then practice. Just practice, and once you practice, and as we continue to go, as we continue to build on, you would understand all of these things. They are not very very difficult. They are things that you would understand, and even when they wake you up from sleep, these are basics. So if they look scary, practice them. And if anything in this life ever looks scary for you, practice it, especially when it comes to the aspect of data, right? So we've seen how to look through, and if you read through this, they explained. You can see here their list is magicians, and they explained the concept of this loop, what is happening, why everything is happening, right? So we can actually do more work with a loop, like you saw what I did earlier on. We added a greeting message, right? Instead of just printing the names, we added like a greeting message. And this dot title here is actually because they didn't you know what dot title does? It actually changes the title casing, right, of the names of the people. So for example here, um these our names are already in title case, right? But let's give them lowercase, right? It's actually wrong to start a person's name with a lowercase, but we have this. So it means if I print this, I still have them with lowercase. So here, if I print these guys, I'll still have them with lowercase, and this is wrong. So what can I do? I can change these casings to title casings, right? So I can make this dot title, right? And do it for all of them likewise. Dot title. But who even cares about this one? We have already moved on from these guys now. And we've gone to loops, right? That is the title. You have dot lower, you have dot upper. Then it also gets you the same job done. And then you see instead of now another reason why you should loop is for correction's sake. Now you can see if I have 1,000 lines now, if I'm going by if I were to go manually, right, and do it this way, it means I will definitely need to correct this on 1,000 different lines. That's already enough headache for me, and I don't want to go through that. So if I am using loop, I will just come here and then I'll just correct it once, right? But on this, I have all of it here. So using loops can never be overemphasized, right? Although maybe as we go up, we'll see better ways. But then using loops can never be overemphasized. Doing more under a list, you can actually add other lines. It's not just one line with it. It's just for practice purpose that I've just decided to add one more line here. For example, here you can come and say um, tea or coffee, tea or coffee. So each time, each person that I greet now, I'll ask the person tea or coffee. So I'll print this. Can you see each of the person? Good morning, Aisha. Tea or coffee? So let me add like a little full stop here so that it will mark the end of good morning, Aisha, tea or coffee, right? And let me run this. Yeah, I have a full stop. But then I want to give a line space in between each of these guys, right? Because it looks too cluttered. So I'm just going to come here and add like a slash n to add a new line after this particular line. So if I print this, what do I get? I have line spaces, right? So that it makes the output more readable. Now, okay, so having this now, there can also be cases where, okay, after greeting everybody, let's say the event is over, right? And then I want to say, I want to print thanks for coming, everyone. Beautiful. Now run this. Thanks for coming, everyone. Now you can see this message appears at the end. Very, very important. Now I know which messages are supposed to be in the body of the loop or the block of code, if you would prefer. If I mistakenly push this one in using the tab key and I run this guy, what happens? You find out that I have thanks for coming everyone, thanks for coming everyone. Like in every, after every loop, I have thanks for coming everyone. Why you have this line space is because of this slash end here, right? So it means for everybody now you see thanks for coming everyone, thanks for coming everyone. And that's actually not what I want to do, right? So we'll see that when we come to handling some common errors when it has to do with loops, right? Yeah. So which line of code joins the ones in the loop and which one stays outside of the loop depends on what problems you're trying to solve, right? We'll talk about that more later, of course. So doing something after a loop, that's what we just saw now. Now avoiding indentation errors. Now, you, the first indentation error is when you forget to indent. You can see in this case now they forgot to indent, and once you forget to indent, you're on your own. Your code would bounce back with error. Of course. Now imagine here we wanted to print nums and then we come back here and we forgot to indent, right? Then you run this guy. Of course you're gonna have issues. Right. So what I just pressed to erase the indent was to use backspace, right? Then it gives you an indentation error because it's telling you that after you have something like after a for statement and especially yeah it's telling you now, can you see after a for statement, right, it is expecting a block of code or at least a line of code, at least. So you must pass in a line of code, at least one, before you can continue with other parts of the code. After a for loop you must add at least a line of code, at least. So it's expecting that. It's more like me telling you, okay, for every member of this class, I want you to actually share a biscuit, but I've not told you the instruction. So I just came and then I met you now. I say, for every member of this class, and then I kept quiet and then I left. I think every sensible human being will follow me up and say, okay, so you started giving my instruction. You said for every member of the class, what should I do? That's exactly what Python is asking you here, right? So, what do we do now? We go back here and we use the tab key, which is like the first key on the third row of your keyboard. If you're using my kind of keyboard, if you aren't, you could just browse online, where's the tab key. Sometimes it is written tab, and sometimes you just have an arrow, right, and a line going to the right and one going to the left by the leftmost part of your keyboard. We run this, of course, we have our answer. So that's the first one. Now, the second one, I'm just trying to stick with the book and forgetting to indent additional lines. This will not stop your code from running. Remember, we said we needed to have at least one line of code. One line of code, yeah, after a for loop, right here. We needed to have this indented. So we have this already. So Python is already satisfied. It will not throw an indentation error for you. But then this kind of error now is going to make you to do what you didn't want to do. For example, in this example that I give, let me just cut this. Okay, yeah, let me bring this guy out. So I wanted to actually ask everybody, like individually, tea or coffee, right? If I run this, I'll ask them tea or coffee. But now, if I mistakenly take this out, this code will still run. Let's see what will happen. Now it will greet everybody first before it will come and ask one tea or coffee. It means I am now asking everybody generally tea or coffee. That works if if maybe we're going to use majority win the vote, maybe we're going to vote or something, right? I don't know. But if you want to ask everybody individually, then this itself will not stop the Python code from running. But this is wrong, right? These are the kind of errors we call them semantic errors. This is the error you make that will not stop the code from running, but then the code is not executing the your intent. Those are the kind of errors we call them semantic errors. The ones that will stop your code from running, like the indentation error, is what we call the syntactic errors, right? Let me just have them here for you. Um, just write them here: semantic and syntactic errors. I pray I got that correct. Yeah, syntactic errors. So the semantic errors deals with the meaning, right? Okay, this code now that you wrote, is it actually running the way it's supposed to? Right, that's a semantic error. Then the syntactic error is where the code fails to execute because of an error from you in writing the code. Right, that's very, very easy to understand. Okay, so we're not going back to the drawing board. Let's go back to our book. So forgetting to indent, you can see what it will, the kind of error it will give you, right? It acts against your own will or your intent. Now, when you indent unnecessarily, right, you have unnecessary errors as well. I call them unnecessary errors, don't mind me. So, for example, you just have something like a message, like what they have there, and your message is hi. Ideally, when I want to print hi, I print it like this, right? Print message, then it gives you hi. But supposing now you forgot and then you mistakenly indent, maybe because of your knowledge of loops, you now indent, right? Using your tab key. If you run this, it's going to throw an error because it's asking, okay, why are we having an indent here? It's not like we have any other statement here, like a for loop statement or something that requires indentation. So there's nothing that requires indentation. Why are we indenting? So Python is actually helping you to make sense of your code, and then it will stop. It will still give you an indentation error, telling you that this indentation is unexpected. Right? Very good. Now indenting unnecessarily after a loop. Now this one will not also not stop your code from running. This is more like what I said earlier on where this thank you everyone. That was a great magic show. This is supposed to be outside of the loop because you are addressing the entire people, right? It's supposed to be outside of the loop, not inside. So if you run this inside of the loop, see what happens. It tells everybody, thank you everyone, thank you everyone, thank you everyone. And that's not what you want to do, right? So you can bring this outside of the loop. You bring this, and of course I understand that sometimes when we are running our codes, for example, if I come here, each time I hit on enter key to go to the next line, it will continue to stay, the indentation will continue to stay, right? So what do? You just use the backspace key and then you erase the indentation and you go out, and then you can print something like done, right? Done. Then you have, right? So what if I mistakenly indent done here? What happens? You can see 11 done, 12 done, and that's not exactly what I want to do, right? So like I said earlier on, when you indent depends on what you're trying to do, right? If we have two problems we're trying to solve, the two of us, we have, different ways we approach our codes. But then um all your codes that are supposed to be indented, right, must come first before the unindented ones. For example, you cannot have print tea or coffee outside, right? If I print this guy, you cannot have print tea or coffee outside and then this one now goes back to be indented. It will throw an indentation error for you, unexpected indent. So it expects all the indented quotes, that is all the block of quotes under the for loop first. Put them here. The ones that you want to print outside of the loop, you come here and then you do that, right? And then you go ahead and you run it. Don't worry, with a little practice here and there and little exercises you put together, all of these things, you'll be able to wrap your heads around all of these guys. Now, moving ahead, let's look at another kind of common error, forgetting your colon. If you dare forget your colon, this guy here, you're on your own. So you don't forget your colons, it's a cardinal sin in Python. If you forget your colon, it will remind you it is expecting a colon after a false statement. So let's come here, let's see practically. Let's erase this guy. Very good. It's telling you that it is expecting this. So Python has a tiny debugger. Okay, let me remove the word tiny. It has a debugger that helps you to be able to trace where errors are. Sometimes the debugging is not that very, very advanced. The one that comes by default with Python is not very, very advanced. That's why if you use code editors like this guy here, Google Colab, or you use VS Code, you use PyCharm and other intelligent code editors. They help you to, to address errors, to fix errors, to identify errors easily, right? And the process of identifying and fixing errors is actually what we call debugging, right? So it actually will tell you if it's able to identify it will tell you, right? Because there are sometimes where this color now can keep you awake for the entire night. You will not be able to know, okay, this is where the error is coming from. After so many tries, you can actually use a debugger. These debuggers help you to be able to identify small errors. But there are some errors that they might not be able to identify for you. They might just tell you this is you have this error. So go back through your codes and try to find out the solution. Okay, very good. Then we fix this back and then we have it up and running. So if you've been enjoying the video so far, kindly just like and comment on the video. It goes a long way to recommend this contents to other people, right? So please just don't just watch our content. Please also like and then comment. Each of those likes or comments goes a long way to recommend this content to other people. Thank you. Keep watching. So you have exercises 4.1 to 4.2. So now if you want to create a list, there are times where you want to create a list of items from a particular number to another number, right? Let's say from 1 to 100, like, right? So what you use to give you that is actually, we have, Python has a function called range. This helps you to create a list, or let me say a collection. Let me put that. It creates a collection of numbers from a particular starting point to a particular endpoint. Right. Let me do this. So now if I run this range and then I in the range, you can see here in range, in the little highlight I have here, let me take a step backward. Now you can see it has a start, it has a stop, it has a step, and the start is optional. and the step is optional. It's just the stop that is not optional, right? Now, what am I saying? You would understand what I'm saying by optional um, and arguments that you must pass in. So, for example, now you can actually decide to the first thing now is the start. So, if I want to create numbers that start from 1 to 10, I can run this 1 to 10, right? If I run this now, what Python gives me is a range function, right, of numbers from 1 to 10. Now, how do I see these guys? Now, if I want to see them, I can use the a function called list, a list function. I can use a list function, right? I can do this. So I'm wrapping the range function in a list function so that it takes these ones, and convert them to a list. If not, what I will just be seeing is a range of numbers. It will just be telling me, okay, this I'm holding a range of numbers from 1 to 10. What are the numbers? Me and you don't know the numbers until you want to print. So if you want to convert the range of numbers to a list, then we wrap it around the list function, right? So let's do this and see. Very good. There you have it. So I didn't teach you in the previous class. Another way to create a list is you can use the list function like this and create. You can just pass in numbers like this, and this, if you run this, this will create a list. I'm sorry, list. Okay, so I think I was expected to pass in this. Okay, so I have that, right? So is either you pass in this or you add a bracket here, whichever one works. You're just basically creating a list, right? So here, what I just did was I told you that the range function itself is an independent function. It creates numbers from one to a particular point, right? But then if we want to see the numbers, so we want to convert it to a list so that we can see the elements of the list. What do? We wrap it around the list function. So this is more like saying list range, if you understand what I'm saying. If you don't, with just one or two practices, you would understand, right? So, like I said, range 1 comma 10, right? This will not show us anything, right? But if we convert it to a list, it is going to show us the list, right? Now we're going to be using this to create some lists, especially lists that we know that already they are sequential. If we need to create a list of numbers from 1 to 1,000, we're going to be using the range function for that. So as we continue to do, you will get used to all of these things as we continue to go. Now, here the only problem I have is that if you look at it, I wanted to create the numbers from 1 to 10, but it stopped at 9. Now, if you understood what we learned the last week when we were slicing lists, remember when we were slicing lists, we said you can start from a particular number and stop at the number before that number, right? For example, if I want to fetch, okay, I have a list called norms. I taught us this at the ending part of last class. I told us that we have norms here, right? So if we want to fetch the first five, what do? We can write from 0 to 5, right? It will return the first five, but then it will not add the fifth, the element at this index, because of course for norms, look at norms. This is the zeroth index, 0, index 1, index 2, index 3, index 4. So it will stop at index 4. If you proceed, this is supposed to be index 5, so it was supposed to print from here to here. So if you wanted to print up to index 5, what do? You just add 1 to this and make it 6. So it prints up to index 5, because this is index 0, index 1, index 2, index 3, index 4, and index 5. So the same thing here happens for creating range. When you're creating, if you stop at 10, it's not going to create the list and reach. It's not going to create the range, or if you call it list of numbers, up to 10. It's going to stop at 9, one less than what you have, right? So if you wanted to get up to 10, what do? Just add 1 here and make it 11. So here you have a list of numbers from 1 to 10. So if you want to create up to 1,000, what happens? You add 1 to 1,000, that makes it 1,001. Please don't go and write it like this, 1,001, I beg. This is how you write 1,001. Sometimes our head can be hot. Now you can see it has generated a list of numbers from me from 1 to 1,000, right? Don't even want to. Let me just save myself and make it 11, 1 to 10. Of course. So you can see how we did it with ease. So if they ask you to create a list of numbers from 1 to 1,000, instead of coming here to create Of course, you can actually do this. You can actually do this. That is, you can actually come here and then create a list. Let me say my norms so that I will not override the previous norms. You can actually come here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know, then continue 11 to up to where you want to stop. You get, but me, it's not me and you that are doing that one. That was on a lighter note. I just mean to say that is stressful a whole lot. And what of human error? You can actually make mistakes. So that is where the range function comes in. So some of these things they look a little bit complicated, but when you compare them to the value they bring on board, you feel okay. So even though they look a bit complex, let me just make friends with them. Right? There are some things that they are not worth it, but these guys are worth it actually. When you look at the kind of list we're looking at creating as we continue to go on the journey, right? So that is what the range function does. The range function tries to what create a range of numbers from a particular starting point to a particular ending point. But let me also show you some things about the range function. In the range function, let's say I want to create a range of numbers from one. Okay, if I just specify 11, this will also do the same thing as okay. This will not start from one. Of course, the default starting is zero. The default start for every range is zero. All right. So if you don't specify the starting point, what do you have? You're gonna have that the number is gonna start from zero. So if you want to start from zero, no problem. Just pass in range and then pass in the number you want it to stop at. It's optional for you to pass in the start argument because the default start is always zero. And but then it's not optional for you to pass in the stop. The stop you can just pass it. If you pass in 11, it generates a number for you from zero to what? From 0 to 10. So if you pass in 10 here, it actually generates 10 numbers for you, right? From 0 to 9. If you count these numbers from 0 to 9, this will give you what? This will give you 10 digits actually from 0 to 9. What if I want to do like a step? I want it to actually start from, let's say, 1 to 10, but then I want it to be skipping one numbers. If it gives me one, let it skip to three, then skip to five, be skipping one numbers. I can actually give it a step two. So this step, what it does is that it picks the first, it drops the first number, then it adds two to the next number it is going to generate. Right? Adds two again, adds two, and make sure that it does not exceed 11. So let's run this and see. So you can see here it gave me 1, 3, 5, 7, and 9. And then when you go to the next number, what will it give you? Is 11. And remember, it will not print up to 11, it will print up to 10. So every other thing here, there is what? It will not give you the 11 value because 11 is even not included in the items it is supposed to bring up. It starts from this guy and then stops at 10. So it cannot go above that. That's why you have from 1 to 9. And if you ask me, that is an easy way to create a list of odd numbers. Right? If you want to create a list of odd numbers, you just make sure that the number you're starting with is odd. And then what do? You add two. Keep adding two. So this guy here, it gives you this. You remember the step function is also optional. So if you don't pass in the step function, let me ask this question now. Let me see if someone is following me. If you don't add the step function, what is the default value? What will Python assume that is the default value? Let me know if someone is following me.
One.
Very good,
It's
very
one.
good, very good. Thank you. So the optional step value is one, right? So whether you pass it or not. So if you pass it, you can see it's still the same thing. If you refuse to pass it, it's the same. But if you want to pass the step function, make sure the step argument, rather, make sure you pass in the start and the stop before the step, right? If you're not passing in the step, you can just pass in the last digit, especially if you want it from zero. Like I told you, if you don't want it from zero, this guy gives you the entire gist. Now, but what if I want it from 11 now and I mistakenly say from 11 to 1? Let's see what happens. Now you can see from 11 to 1, there is no element because you are telling Python to go backwards and Python is not going backwards because the default increase is plus 1. What you're telling Python now is you want it to move from 11 to 1, right? And then Python does not understand moving from 11 to 1. especially that it understands that the default step is actually plus one, not minus one. So, but if you want it to give you values in decreasing order, you can actually come back here and do minus one here, just passing minus one. So this Python now is actually reducing one each time it goes. So it picks 11, it reduces one, then keeps it. So initially, what you were telling Python was to add one, and then Python was like, how can I add one and then move to one? It's not possible that I add one and I move to one, but I can subtract one and move to one. I can actually subtract one and move to one. But if I add one, I cannot go to one. There's no way I can go to one. So Python will save you the stress and then just return an empty list for you, right? So if you do this, what do you have? You have an empty list. But if you tell it, okay, so I want you to move to one by subtracting one, and it gives you that. If you want it to move to one by subtracting two, it gives you that. Now remember, it will not also add. Let me see by one. You remember it will not add this ending value. Remember, it does not add the ending value. So that's why in this list you find out that one is not included. Just before you try this out, you can use a for. So I can use for I or for x. Let me use x since x is maths and all of you know x is maths. So let's say for x in let's here we don't have to pass the list. We can just call it the range function. We can just call it in the range function from 1 to 11, right? We can tell it to print print x. And what does Python do? Okay, I have an error. So you say okay, print. I'm supposed to put in this in a bracket. Okay, print x. So you can see what you did. What they did here. So here I don't. If you pass in the list, it will still work. It will still work. That means you converted it to a list before continuing. This will still work, but you don't have to. I'm just telling you that if you're using the range function directly in a loop, you don't need to pass the list. This passing of the list that we did was to convert the range function to a list of elements. But if you are using it in the for loop, you don't really have to pass in the list. This is when we are generating a list with the range function, and this is when we are looping using the range function.
So, excuse me, sir. I noticed that when we are doing the drop down list, it's stopping at two. So, what if I want to make it stop at one? Because I've been trying to see how I can navigate to do that.
Okay, who can help her? She said this one that is descending, going down. She has been trying and then it's stopping at two. What if she wants to is to stop at one?
Put that can I answer?
Yeah, please go ahead.
Okay, you use zero instead of one.
Beautiful.
Like a level from a one. You use
Beautiful.
zero.
Beautiful. So you take it one step downward. Since it does not include this one, so you take it one step downward so that it will include it. Now let's see this. Then you have it there. At least I like the class that is you people that are answering yourselves. Using the range function to make a list of numbers, we can see that here, right? Wrapping the range function around the list to create a list. So you can actually call the list in a name. You can you can assign it a variable, more like numbers is equal to this. Then you can call it, right? Just like here, I can call this nums is equals to list. Let me check what my nums is first of all. My nums is a list of numbers from 1 to 9. So if I want to recreate this now, what do I do? This is going to be list. Then I pass in the range function, right? Then the numbers is going to be from 1 to 10 correctly. And then let me print nums now and see. Of course, nums is now a list numbers. Why is it a list? Because we've wrapped this guy. We are now saying, okay, so convert this range function to a list. That's what we are doing. If we want to convert it to a set, like my friend Fawas was busy with sets over the week, if you do this, it will convert this guy to a set. And you can see this as a set. If you want to convert it to a tuple, which we're going to see later on, convert it to a tuple, right? So it's not like the list is just trying to, you know, show us that we can actually convert these guys to a list. So basically, we've seen how to create lists, numerical lists. We're just going to see more how to work on numerical lists. And we have basic statistics that we can see with numerical lists, right? We can just use having the list, we can be able to see the maximum, the minimum, and the sum of all digits that we have, right? You can see the maximum, the minimum, the sum. Those are the ones we have available. So what do? We can come here. Of course, we already have our norms. Let me just confirm. Yeah, we have our norms. So we can actually come here and say minimum of norms, right? And then it's one. Somebody will say, why type minimum when I know that the minimum is just the first element? Okay, calm down. Sometimes this life is not balanced. Sometimes the numbers can it might not be generated. Here we just generated the numbers that are that are sequential in order, right? So that's why, of course, the minimum is going to be the first element and the maximum is going to be the last. But what if everything was just randomly picked, right? Let's say I have another. Let me just call these values. Or let me call these ages of people in this class. Then I have maybe 26. I have 25. I'm happy to even tell you that there are some people that are not up to 20 years in this class. Yes. One of my last graduates the other time, I don't even know how old that boy is, but 12, you know, I have 10, or maybe, no, I don't have 10 in this class. Let me start 18. I think I have 16 in this class. Let's say I have 21. So you can see everything is scattered about. So this is just for how many numbers here? I just have five. Imagine we can be able to generate 1,000 random numbers, 1,000 random ages. How will you be able to know the minimum? All right. It means you have to be searching all of the values and you have to remember all the values for you to be able to know which one is the smallest. So that is where the minimum function comes. You can just do, okay, what is the minimum of ages, right? And then you get this. Remember, in your assignment, I think you might want to print it. You have to print, then you call the minimum function, and then wrap it around the list. So what you're telling Python now to do is that you're telling it to, this is the minimum function. It will take a list and then check, this is the list. It will take a list, then it will check for the smallest value, and then it will return it. That is what we get here, right? What if you want the maximum? In the same vein, you can just use max as already that. I love Python. Python speaks my language. It speaks English. It speaks Oyibo language, not my language. It actually speaks Oyibo language. Then you have this. If you're watching us from another country, when we say Oyibo in Nigeria, we mean white man. So max, minimum. What if we have sum? We need sum of ages. So what does this return? It returns the sum of all of the digits there, right? So this also, guys also work with they also work with the range function. For example, if I want to return the sum of a range of numbers between 1 to 1000. Remember, if I want numbers from 1 to 1000, I have to make it 1001, right? So if I run this, it is going to return the sum of numbers from 1001. You don't have to create a list first of all. So some things are just mysterious in Python, right? It takes this range. This range actually returns something that is arbitrary. It wants to be on the safe side. It does not create a list. It does not create a set. It does not create a tuple. It just generates a collection of numbers, which are not a list. They are not a set. They are just a collection of numbers, and it will not display them. But if you can decide to now say, okay, I will convert this guy to a list. I can convert this one to a set. Oh, you continue from there. Okay. So list comprehensions. So squares, of course. We've seen how to, okay, this one is list comprehension. They didn't talk so much about list comprehension, but I'm going to explain list comprehensions for you. Now, list comprehension is, for example, let's take, I'm going to use two examples to show you now. Now, please look closely. Look closely. I'm going to try to explain this guy, list comprehensions, right? So now I'm going to try to use something with loops, and then I'm going to try to use to create it in an implicit way. Now, for example, I want to create um, a list, let's say for I in range, that is for every element in this range, in this collection of numbers, range of numbers from 1 to 10, that is going to be 11, right? Let us start with printing the elements first before we go to what we want to do. Okay, we have numbers from 1 to 10, right? So now that we have numbers from 1 to 10, what I wanted to actually do is I want to return the squares of these numbers, right? So I can just pass in this guy's power 2, right? Remember, this gives me my power, right? So I run this guy and I have this, right? So what if I want to create a list with this guy. So what I will optionally do is I can create first an empty list. I can just call it, let's say squares, right? I can create an empty list called squares, and then just an empty list. Then each time I do this, remember this is just an operation and any other operation can be carried out. It doesn't have to be print. So I can come here and then actually do squares. This is an empty list. So I can do dot append ads, right? Dot append I. If I do this, um, okay, let me do this. Let me create an empty list called numbers, right? And let me do here numbers here dot append so that you understand what I'm saying. So here, if I run this, nothing will be get printed out because what I literally did here was what was when I came here, I said, okay, for each number in this range, for each value or for each element in this range, what should it do? It should append the element to this, so it will add it to the list. So the numbers now has been increased, but we did not print the numbers to see. So this is how we see. Let's print the numbers list and see what it looks like. Remember now that it was empty, but here see what it will give us. It will give us a list of numbers, right? So it will give us a list of numbers. Now, what if I want to square the numbers, right? Maybe let's say I want to square. I can create an empty list. So while it is appending the numbers, I want it to also append the squares of the number. And that is like append what? What will I now do? I'll name it I power 2, right? Because this is square now. So it will append the square of the numbers now each time it comes. And then, so now here I printed numbers. That's why you have this. So let me print squares now. Beautiful. So this is I can just go ahead and delete this one if I don't want. I just use these numbers now to show you illustration. So let me just take it once more. If I want to create a list with squares of numbers from maybe 1 to 10, what I will just do is I'll create an empty list called squares, an empty list, don't forget. And then I'm going to use a for loop for each item in range what? 1 to where I want to stop, 1 to 10, right? And then each time I come, what do I do? I can do this. I can do squares. That is that list. This list I've created. I'm going to populate it now by appending what I. So each time it comes, it picks 1, it adds, picks 2, it adds, up until it gets to 10, then it stops, right? But how do I know that this has been populated? Because if I run now, nothing happen. But if I try to print the squares list, what do I do? What do I get? I get from 1 to 10. Oops, I did not square it. Beautiful. So I get this. Now, what I want you to focus on now, what I want you to see is that this is actually a long way of doing it, but this also works. This is a long way of doing it, but this works. Now we can summarize this entire guy now in one line. In fact, this guy like this, we can summarize it in all these lines. Now we can summarize it in one line. Now this is the optional way we can do it. Okay, here you can actually come here. If you feel okay, appending this guy directly is going to be a problem for you, you can just come here and just maybe call it a number. Let's say square. Here is equal to I power 2, and then here you pass in what square here. So here it means you first stopped and then you assigned a variable square to what do you call it, to the number it picked power 2 before you append. This will still give you the same thing as just bringing this guy here. I'm just trying to explain to you the power of variables now. If you want to make your code more readable, you can go about it like this, right? Though when code becomes complex, we have to balance readability and then the length of code again. I'm just trying to not leave anything out, right? Because I know that the journey we have ahead is far. I'm not just teaching you Python because we want to joke. We want to go for data analysis and the rest, right? So you need to understand all of those things so that once we start getting deeper, you're not confused with what I'm doing. Of course. Now, like I promised you, we can actually do these guys in one line. So we can use list comprehension. Now, let me write the list comprehension so that you understand. Now, I can just open a list and then I can tell you, okay, I power 2 for I in range 1 to 11. That's all. Let me run this and you see. Beautiful. I have the same thing. So this is what we call list comprehension, right? Where you in list, and I think I'm not sure of tuples. It has been a long while, but we have list and we also have dictionary comprehension. When we go to dictionaries, it also has this language. List support this kind of language. It supports a language where you can write a for loop inside of it and then it understands. So instead of first creating an empty list, then coming to use the for loop to populate the orga, you can just come here and then write this thing I power 2, and then you're telling it where the I is coming from. For I in where is coming from this range of numbers. Let me take it again. You specify the operation I power 2 for I in range 1 to 11, and then it does this for you. Now I can just assign this one to, I can just give it name squares is equal to, you know, I just have this. So if I want to print my squares, I can just come here, then print my squares. Now you can see these comprehensions are faster than normal lists. They are faster when you're carrying them out. Here, I know if I just run this guy now, you don't need to see it with your naked eye because the operations don't take up to a second. They take nanoseconds, microseconds. So you won't be able to see it with your eye. But it is when you will now have 4 million or 4 billion or 4 trillion rows that you're dealing with. That's when you will now see the slowness in how it carries out the operations, right? So I'm trying to open up your mind because we are not just learning this thing for fun. We are going somewhere. So I have to open your mind to every other thing that is available, right? So here is list comprehension. So what I want you to do is I want you to learn both of them because sometimes the list comprehension might look too lengthy. For example, now there are things where the operation this is just square, so you can just go directly and put here. But there are times where you have to do a lot of things. There are some operations that you have to carry out before you will now go ahead to now add it to this list. So if you do a list comprehension directly, it might be too lengthy for you to be able to write. And so take the two operations at the same time and work with them, right? So we've seen list comprehensions, and so from here you can be able to do this and get. You can see here list comprehension, right? Very good. Now, working with part of a list, we did this, so I'm going to skip this. If you watch the ending part of last week's video, we talked about slicing of a list, right? I actually thought we were supposed to cover it last week. I didn't know we were supposed to cover it this week. So slicing is just cutting a chunk of the list. I don't want the entire list. I just want a chunk, right? So we can just try this out and see it in the Python environment. So here, now look at what will happen here. Let me. These are players. Let's assume these are basketball players like Fawaz, right? Now, so we have. Let me just remove one name here and put Fawaz. Let me remove Martina and put Fawaz so that it will make more sense. Yeah. So we have players like Fawaz, and of course, if I just print players now, what do I get? I get the entire players, right? But what if we want to just cut a chunk? We want to cut only from the first person to the third person. What do we do? Remember what we did last week? We said we are going to start from index 0, right? And then we get it to the third person. This is like index 0, this is index 1, this is index 2. So if we stop at 2, what happens? If we stop at 2, it only prints 1 and 2. It only prints from index 0 and index 1. Remember what I was telling you? It does not add the last one, right? So if we wanted to print up to Michael, what do? We put index 3 so that it prints from index 0, index 1, index 2, and then it stops. It does not go to index 3. Very good. So you remember if you're starting from the beginning, this 0 is optional. You can even just put it like this, then it still works. If you specify it like this, it means you're starting from the beginning. But if you want to start from, let's say, the second one to the third one. You can just do this index 2. So from index 2, where is index 2? 0, 1, this is index 2, right? So you just print Michael, and then you cannot go to index 3 because index 3 is not included, right? So what if I make this to index 4? Of course, it prints Michael and Florence because this is index 2, this is index 3, and then you cannot print index 4. Remember, this is 0, 1, 2, 3, 4. So this is like me printing from 2 to the end. Now, what if I don't know the end of the list to specify? I can clean up the last guy and then, do this. And what happens? It prints from the beginning, right? From where you specify, from the starting index to the end. So remember this, that if you print from this like this to 3, what does it do? It prints from the first element to 3, and then if you specify from, let's say, 3 to the end, what does it do? It start from the third index, that is 0, 1, 2, 3, and then it goes to the end, right? Now what if you now specify, let's say, from index 1 to index 3? What happens? It prints index 1, index 2, and then it stops, right? So index 1, index 2, and then it stops because it cannot go to index 3. Remember, we spoke about that. And what if I wanted to, what if I do this? So if I do this, it prints everything. So that is another way to copy a list. There are two ways you can copy. You can copy in such a way that it will have an effect on the original list whenever you make changes to this. Okay, let me do this. I have players, right? I have players. Then let me also create another list, my players. Let me just call them my players. My players. Like this. Then I say is equal to players, right? In my imagination now, I have copied this list, and actually I have copied the list. But then this time around, see what happens. If I print this, you can see here is a copy of this list. Now let me pop. Remember, pop removes the last element, right? Let me pop here my players.pop. So it takes out Eli. Now let me run my players. Let me try to print it. Network issues. Okay, so you can now see that this my players does not have Eli. Now let's go back and look at players. Let's just print players now and see. You find out that players also does not have Eli. So if you copy a list like this, whatever you do affects the original list. That is why we have to copy it properly, right? Because this is just like you assigning another name to this list. This has now become like a middleman, if you will, if that works for you. So whatever it is that you do to this one, it will correspondingly affect this one, right? So now, what if I want to create a list that will not affect this one? Let me just go ahead and run this one again, so that the list now has not been initialized with Eli inside. Let me do this, then I do this, just like we have here, right? If I do this now, it will copy it and it will not affect it. So try this out. Let's pop Eli. Now you find out that in my players, Eli is still available. But let's print my players now and see if Eli is available. Find out that Eli is not available. So we've successfully copied the list in such a way that it now it is not affecting the parent list, right? So now, in order to another way you can copy, if you don't want to use this guy, another technique to copy, I told you is to use the dot copy, right? So you can use option two is you can use my players is equal to players dot what the dot copy method also does the same thing as this guy will do for you. So if I run this, find out that my players has been removed, but players have not been affected. Has not been affected rather. So great, great. I think we are bringing the class to a close. So that's what this entire English has been saying is about slicing. And then looping through a slice is the same way you loop through a list. So there are some times where, okay, so I just want to loop over the first three elements, right? It's the same way. So you just come here and then you just specify, okay, players. The only difference now is that you just specify the range, right, using this. Of course, do you need me to do this? I think I don't. Okay, let's just use one of our list here. What do you call it? This guy. We've done a lot today. Okay, so here, if I want, I can just say, okay, so let's just do for the first five, right? From here, right? For the first five, let's assume we want to just print for the first five. So this we return norms from where to where? From the first number to the fourth index, right? From the zeroth index to the fourth index, right? So if I run this, it will not do for all of the numbers, it will stop somewhere, right? It will stop at this is the zero index, one, two, three, to stop at here four. It cannot go to here five, right? That's what happens. So you can actually specify for just a chunk of the list. You can specify whatever it is that you want to specify for just a chunk or for a slice if you want. That's what we call either a slice or a chunk. All of us have sliced bread before. Even if it's not the one that came sliced, you must have cut off some part of a bread. So maybe let's say some of you in your house they used to share bread for you. They don't used to keep bread in the dining. And because they know if they keep bread in the dining, the life of the bread will never remain the same. So they will cut a portion for you and then keep this is your own now, whatever you want to do with it. So just I like relating these guys with you know what we have, what works around. So that's how to look through a list. And I've also shown you how to copy a list. Beautiful. So you have these exercises to do. So in rounding up our class, we'll just see another data type similar to lists, but this time around called tuples. So tuples are just like lists, but the only difference is lists, right, are mutable. When we say a collection is mutable, it means the elements can be changed. And you saw that with lists, um, we can actually add elements and we can actually also remove elements from a list. But in a tuple, we cannot add and we cannot remove elements in a tuple. Though we can sort elements the same way we have done with other what do you call them now? With other elements. You can sort, yeah, you can sort, but you cannot add or remove. You cannot change the content of the collection. You can also slice them, you can also index them exactly the same way you treat a list. But why do we have them? Is because there are some times where you create a list that okay, you don't want this list now that you've created now like this. Nobody is going to touch it on it. Nobody should touch it. It's static. Then if you use list, if you use tuples, you are safe. But if you use list, it means anybody interacting with your this thing can change the anybody interacting with your code or later on the user can change the content of the list. Lists are less applicable. Sorry, tuples are less applicable than lists. Lists are always common because sometimes, for example, now the users in a website, right, is not static. You might the number of users or the list a list containing users in a website changes from time to time, right? So you cannot come and say that you are going to use a tuple. If you use a tuple, it means once we've created and then these are the users, boom, these are the users, and nobody is going to add or remove. Those of you who have a little touch of math, you know what we call coordinates, right? Coordinates are like the position of an object in a space. So the position of the object mostly does not change, right? For example, it's not like you now that you like yeah, you move from place to place. But if the coordinates of let's say you put this on a space and the coordinate is 2 comma 4, that is on the x-axis is 2 and on the y-axis is 4, so let's assume it's going to continue to stay there, right? That's the coordinate of the point. So now when you have in that kind of case the best thing to use is to use a tuple. If you use a list in that case, the list can change at any time. In fact, the list can add another number. So it's better to use a tuple so that when somebody is trying to change the tuple will bounce it back to say tuple, the contents of a tuple cannot be changed. Of course, enough of the long talking. We're going to see that. So when you're defining a tuple, you do the same thing like you do for a list. The only difference is that you're not using square brackets, you're using normal brackets. So some of you that have used normal brackets before, we are back again. Some of you have seen in your work you've used normal brackets and you've encountered errors that you have to come back. Right. So let's see tuples. So let's say my tuple now I want to create tuple. My tuple is equal to let me create this. 4, 5. This works. So if I print my tuple, okay, let me just call it T for my tuple, empty rather. Okay, so you can see here I have it. Now, if I print the type of my tuple, let's say type of my tuple to see the data type, it's going to tell you that it's a what? It's a tuple, right? So tuples are like lists, but are not mutable. So now let's try to access the first element. The first element is going to be what? The zeroth element, and then this works. So indexing and slicing also work here, right? You can also print from zero to the third element. So 0, 1, 2. So it prints. You can see it also works just like you have with list, right? You can also even copy the entire thing. You still use square brackets. Yeah, you still use square brackets here. This is for indexing now, not for list, right? You can see it still created everything, still copied everything. And you can, I think you can also use the dot copy. Let's try that out. Okay, it will not work. It doesn't work here. You cannot append. You cannot do dot append to throw an error. If you append one, it's going to throw an error. Why is it going to tell you tuple object? It doesn't have any attribute self that is called append. So you can't add append. You can't, you can't remove. You can't delete. You can't do anything. Once you created, it's only always created. So like I told you, it's always used for coordinates, right? Let's say we are creating the coordinates of x, and then we are given x 1 comma 2, and that's why you find out even in math coordinate system are always written in this form, right? So you do this, there is nothing on earth that will change the value, this thing that is inside of this place. The only thing you can do is if you come back here and then you say, oh, okay, so this x now is now going to be 2 comma 5, then this thing now will work. Let's see, here, print x, then let's also print another x here. If we run this, guys, what happens? We have 1 comma, this, it prints the first one, that's what you have here, and then when you move forward it now prints what? This one. So supposing you take this one out, which one prints? It actually prints this one. So the only way you can modify a tuple is actually to reassign the same variable to another different tuple, but it's not like adding or removing elements, right? And we saw that Python allows for this, right? You can type in, you can say x is equal to 2, later come back and say x is equal to 3. Python will take the most recent update and then it will go ahead. So here it has updated the value of x. It's not like it has changed the tuple itself, just updated the value of x. And then there are sometimes where a list can have just one element. A list can have just one element in it. But a tuple, if you want to create a tuple with just one element, you have to do this. You have to add like a comma behind it. So if this was a list, let me try this ml for list, for my list. Let's call it this one. Now, if I print ml, what happens? You can see it is actually a list with just one element. But if I do my tuple and I put my tuple equal to just one and I run this, let me print my tuple and see what I get. What do I get? It will just return the integer one. So if I want it to be in a tuple form, I have to bring in like a comma here, like a comma here, so that it actually it's just even though it's rare that you have a tuple that just has one element, but if you really need that one element to be a tuple, you would have to create it and you have to add a comma here. If you don't, what Python will just do, it will assume that it's an expression you want to carry out. Remember, parenthesis is also part of the operations we spoke about. It's more like multiplication. So Python will just take it as multiplication and pass. So it will take it as, okay, so here is an invisible one multiplying a one. So if you do this, it will just return one for you. And if you type, if you want to, if you doubt what I'm saying, just do this type of empty, it returns an integer. Except if maybe you come here, then you do tuple and then this, which I think will return an error, except if you add another bracket here. Let's see if this works. To still throw an error. Yeah. So the only way to do it is to come here and then add one, a comma after the one, or after the digit you've added. Just add a comma. Then you have that. So you can actually also look through tuples in the same way you looked through lists. Can you see? For for this in this, do this. For this in this, do this. Still the same thing. Um, where was that? Where is my tuple? Empty, right? Here. So empty is equal to this. I can just say for I in empty, that is in my tuple. What do you want? What should you do to throw an error? I didn't finish up. So I want it to print what I. Can see? It also works with tuples. Alright, nice. So let's also see. I also don't think tuples accepts integers, but let's sorry, strings. But let's see. Um, let's try to do this. Let's call this Aisha. I think we had Aisha. We don't even have an Aisha in this class. Do you have a Mariam in this class? Yeah. Let me see this. Oh, okay. So it works with strings as well. Okay, nice. So let me do this type. Tuple. Okay, it also works with strings. Nice. So you can actually also use that. But remember, the collections of a tuple are not mutable. I'll ask you this question. The meaning of mutability, mutable, mutable, is that the contents are changeable. If we say immutable, it means they are not changeable. So another, I've given you a new vocabulary today. If you don't know, if we say something is mutable, it means it is changeable. If we say it is immutable, then it does not change. Very good. So I think that's all, except styling your code, which is just a way of showing us that if you, I want you to take some time, take some 5 10 minutes and read these guys. You know, you remember in the first class we spoke about Zen of Python, which is actually like some kind of a guideline for us, right? Developing Pythonic codes that look like actual Python developers, right? So here is just another step to build on how to style our codes, how to arrange our codes, right? So there is what we call PEP 8, right? So PEP 8 is actually a list of, is a long list of plenty of things that you're going to read. Let's just let's look at that. PEP 8. You can see PEP 8 guidelines, Python enhancement proposals, right? That's what they call them. So PEP 8, I think, is the eighth edition, if I'm not mistaken. So, and this was created in July 2001. So here is a list of the things you are, in fact, they are going to be explaining some of the Zen of Python, and when you should do this or why you should do this. Most of the things that they are going to tell you, it's not like if you disobey them, that your codes are not going to run, but they are going to try to explain to you, okay, so what we want is this is how we feel a code should be written for efficiency and for readability, right? And you can see all of them. It's a long document. It's a long document on how to work with variables, method names and instance names of variables, how you are supposed to name methods, how you're supposed to name. Don't worry, we're going to come and see some of them as we are going to go. So for those that concern, what we've done today for list is what they've taken some time to tell us some things here. The style guide is actually PEP 8. I've told you what PEP 8 is, and you can just browse for PEP 8. Take some time, some 30 minutes and read. Nobody's going to ask you any questions from there, but then it helps you to know what you're supposed to do better. And it also helps you to understand why I do some things. So here, the first thing is indentation. So for indentation, is actually some codes use some platforms like this guy here, they give you 4 spaces, while some in the tab spaces they give you 8 spaces. So it depends. But for PEP 8, I think they said, if I'm not mistaken, use tabs rather than in spaces for indent. This works well. I'm just trying to find out that place. Convert, yeah, if you use the tab key, it converts each tab to a number of spaces. Now this number of spaces, if you're using them, it depends on your code editor. Some code editors give you 8 spaces, like I said, while some give you 4 spaces. So in the case where you have that, I think according to PEP 8, I think they prefer 4 spaces instead of 8 spaces, according to PEP 8. Ehen. But most of us, once we just go, anyone, the one, the any once we just press the tab key, any number of spaces it give us, we just want to use it like that. According to PEP 8, I think it's supposed to be 4. I can't find it here. Yeah, but the indentation is supposed to be, I think it's supposed to be 4, right? So, but then indentation is actually very, very good. And you know the importance now. We just saw the importance, right? If you indent wrongly, you're going to have a wrong response from Python. And then the length of your line, right? That is how many characters should actually be on a particular line. The lines for now are not long. It's high as how many items we have here. If you count from here to here, I doubt it will be up to 30 characters, including spaces. So according to PEP 8, your lines are not supposed to be more than 80 characters. In fact, they should be less than 80 characters, right? You can see here we have a 79 character standard line length, right? So the line length must be below 80. If it is more than 80, Python has a way you can link 2 lines together. So you take it to the next line, right? You take it to the next line. So it's because of readability. It's because of readability. So that if I zoom this guy out, I should be able to see everything. If you check from here to here, if you count the number of allowable characters, I think they should be up to 79 or so. But if you pass now, you find out that I have to scroll before I see. So we want to see your code at a glance, not scroll from left to right before we read what you have. Some of us will still default to that, and it will still run. Your code will still run even if you have 1 million characters per line. But the problem is that now your codes are not looking professional, right? So I'm just showing you styling your codes. Now, other style guidelines, of course, they said you can see them in PEP 8 guidelines. We're going to see more of them as we continue to go as it concerns each chapter we do. We're going to see them PEP 8. So, in as much as we know that we can write good codes, but we also need to know what the community of Python developers, what is agreeable amongst them. And then, so we also keep up to standards. If you're a community member and you don't keep up to standards, you're not recognized by the community. So, if we want to be recognized by the community, if we want to, and here is another very, very good reason. Is why we agree on PEP 8 is because I can be a Python developer myself, you know, and then keep to some kind of rules and regulation, my own rules and regulation. And then we can have another Python developer in another community somewhere there, you know, writing his own code and then just keeping his own principles. Now, the problem is when two of us are now given a particular job to do, which of course that's how Python developers, in fact, that's how developers are. They are made to carry out tasks together. You have to collaborate with people to write code. So if I write my own code the way I want to write, and he also writes it on the way he wants to write, now if we will not agree because his code will be difficult for me to read, my code will be difficult for him to read, right? So why we need to style our code to PEP 8 is so that when we come together, his code is not looking strange because I can read it. It is aligned to PEP 8 guidelines, and then my own is also aligned to PEP 8 guidelines, right? That's the most important. That's why we need PEP 8 guidelines. Is they are trying to bring in some kind of a playing ground where both of us have now become equal. So you have to style your code according to PEP 8 guidelines. You need to. So I think I've given you enough reason to know why you should style your codes to PEP 8 guidelines. That was a lot, right? So today you learned a lot. You learned how to work with lists. You learned how to look through lists. You also learned how to look through chunks of lists. You learned a lot basically, right? And it was great, right? Learning. Like I said, practice makes you perfect and it makes you understand some of the things I've been trying to use words to describe, right? Sometimes words might fail us, but then when you begin to practice, right, you begin to make sense of whatever it is I was saying. Beautiful. So we continue next class. We're going to be looking at if statements in next class. Until then, please enjoy learning. Don't forget to like and leave a comment, a beautiful comment on our video. Thank you. Thank you for the feedback already. See you next class.